Hello, guys. Welcome back. And today, the discussion will be a really interesting one. It's a question that I really pondered upon a lot, and every student ponders upon a lot. That why certain things happen in the definition of testing a hypothesis. What is a certain thing? By the way, I apologize for the mumbling and this of my words because I have a toothache and my words may not be very clear. I'm trying my best to be clear as much as possible. So the goal of today's topic is to understand that why in testing of hypothesis we fix the type 1 error and we reduce the type 2 error to get the best test. Now, so the question may come that why we don't we fix the type 2 error and reduce the type 1 error? What will happen then? We will see and discover what will happen today. So the prerequisite to understand this talk i- is to know about the basics of testing. I will link a video to this corresponding talk to understand the basics. That's a prerequisite. But as you can understand, the goal is to fix the type 1 error at alpha. We know that the goal in to find the best test is to fix the type 1 error at alpha and minimize the type 2 error to get the best test. That's what the statistics community has done all these days. But why? That's a natural question, right? So let's revise that in a statistical test, if the truth is h naught and h1 respectively, and if the data shows h naught is rejected and h naught is accepted, or h1 is rejected, there are two kind of errors. One, when h naught is rejected given h naught is true, and another is when h1 is rejected when given h1 is true. And these two are called type 1 error and type 2 error. As you know that the probability of these two errors are called type 1 error and type 2 error. Rather, the probabilities of these two errors, yeah, are the corresponding errors, like find the probabilities of these errors. Now, there are many ways in Bayesian statistics. There's a different way to find the best test, but in here, we are discussing the optional paradigm where against the actual way we do it, we find the best test is that the actual way we do it is in the rate format, that we fix the type 1 error at some point at some alpha level alpha, and then we minimize the type 2 error to find the best test. But there can also be another option, right? We fix the type 2 error at some point and we minimize the type 1 error. That is another option, right, guys? So now let's see, what happens if we try to do that, we try to find that. So let's take the scenario where x1 x2 xn, the norm, the easiest scenario when x1 x2 xn is a sample from normal mu comma sigma square is known, and we test the corresponding h naught where mu is equal to 1 versus h1 where mu is equal to minus 1 versus mu is equal to 1. We're testing whether mu is equal to minus 1 versus mu is equal to 1. H naught versus h1. Also, after this talk, after listening to the watching this video, you will get to know that what is the meaning of null hypothesis and what is the meaning of alternate hypothesis. What is the purpose of these two hypotheses? Are they same? Are they different? And we will see and discover it towards the end of this lecture. So we have a normal sample from mu comma sigma square. The variance is known. We are trying to test the hypothesis whether the mean is equal to 1, minus 1, the null hypothesis whether mean is equal to minus 1 versus the alternate hypothesis mu is equal to 1, mean is equal to 1. Let's take a corresponding opposite scenario where you test where the null hypothesis becomes alternate hypothesis and the alternate hypothesis becomes a null hypothesis. That is, you test h naught star where mu is equal to 1 versus h1 star which is mu is equal to minus 1. You just swap the two hypotheses and let's see what happens. In the black case, when mu is equal to minus 1 versus mu is equal to 1, the type 1 error is probability h naught is rejected versus h naught is true. Now, if we take the case, like second case, the red case, where if we calculate the type 1 error in that case, it's probability h1 is rejected, like probability h naught star is rejected, given h naught star is true. But h naught star is same as h1. The hypothesis h1 is mu is equal to 1. So it's the same as the type 2 error. So the type 1 error in the first case, in the actual case h, where mu is equal to 1, minus 1 versus mu is equal to 1, the type 1 error in this case is same as the type 2 error in mu is equal to 1 versus mu is equal to minus 1, and vice versa. So type 1 error in this case is same as type 2 error in the second case, in each complement case where it's swapped. The type 2 error in the original case is same as the type 1 error in the swapped case. This is very interesting, and we will use this find find the alternate, alternate way out of this way out, fix the type 2 error and sub point and minimize the type 1 error. Now what we will do is that we want to find the two different type of tests, right? Where type 1 error is fixed and we minimize the type 2 error, and that's where what we get the MP test, the most powerful test. I will link the video. I have linked already the video, or I will link it here. The two videos you need to watch before you need watch this video. That's a prerequisite. So the MP test, the most powerful test of this musical to minus 1 versus musical to 1, the H case, the original case, is found by the name and Pearson lemma. We will find that. But if we fix the type 2 error and minimize the type 1 error of H, it's same as fixing the type 1 error of H complement and minimizing type 2 error of H complement, right? So therefore, it's the same as the MP test of H complement. The same as the MP test of the H complement, right? So therefore, let's find out the NP test of both this case, and it can be done by this general case that mu is equal to mu naught versus mu is equal to 1. I will write down the results. That, let's say we are testing mu is equal to minus 1 versus mu is equal to 1. In this left hand side, we are fixing type 1 error and minimizing type 2 error, and that we get the MP test of this scenario, mu is equal to minus 1 versus mu is equal to 1. And in this case, if we fix the type 2 error and minimize the type 1 error, then we are getting the MP test of mu is equal to 1 versus mu is equal to minus 1, right? Now if we solve general MP test of mu is equal to mu naught versus mu is equal to mu 1, as x bar is a sufficient statistic of mu, and we know x bar really approximates mu well, we will get that we reject h naught, we reject the fact that mu is equal to minus 1 when xn bar is equal to minus 1 plus, that is minus 1 plus some constant c alpha. And if we find the MP test of this case, then we will see that we reject h naught star, that is mu is equal to 1, if xn bar is less than certain 1 minus certain quantity, and we reject h1 star, that is h naught here, that is we reject mu is equal to minus 1, and we accept mu is equal to 1 in this case, in the right hand case, if xn bar is the opposite of this, that is xn bar is greater than or equal to 1 minus c alpha, the same c alpha actually. So what do we get diagrammatically? We got that c alpha is this quantity. We got that in the first case, if we fix the type 1 error and minimize the type 2 error, we get that we reject that mu is equal to minus 1 if the mean is more than on this side, on the yellow side, on this side, the mean is on this side. And if we fix the type 2 error and minimize the type 1 error, we get that the mean, if we reject the fact that mu is equal to minus 1 if it's on the green side. Now what is the difference? Both are of the form xn bar greater than some constant. Both are of the form this xn bar greater than some constant, c1 here, c2 here. But what's the difference? So yes, I have stated some result. You must check it yourself by hand and do it mathematically and check that this is the same thing. But what is the difference here? In one case, the difference is xn bar we are rejecting if it's minus 1 plus certain quantity epsilon, and another case we are rejecting xn bar is greater than 1 minus certain epsilon. Understand that this epsilon is in our hand. We can vary this epsilon however we want by varying the alpha. So what does it mean? It means that in this case, we can keep epsilon very close to -1 also, or very far away from -1 also. So here the focus is -1, that is mu is equal to -1. Like, and here the focus is mu is equal to 1. Now, why the focus is shifting? If you can understand that in here we are fixing type 1 error, that means we have the control of the type 1 error. We have the control that when h naught is rejected, and here we have the control when h1 is rejected. So therefore, in this case, if we fix the type 1 error, we have control over mu is equal to -1, that h naught. That means we must make sure that h naught is rejected first properly. We must make sure that h naught is rejected first properly. By properly means according to our level of significance, according to our error, uh, the how much we can tolerance. But here, if we fix type 1 error, that means h naught is first rejected properly according to our tolerance level, and then h1 is accepted. Or we don't say h1 is accepted, we say that we don't have enough data to reject h naught. So fixing the type 1 error is actually putting focus on much more on h naught. We are making sure that h naught is rejected properly. So the goal is to make sure that h naught is rejected properly, the usual way of test. And here, if we fix the type 2 error and minimize type 1 error, it's making sure that h1 is accepted properly. That means it's close towards 1. That means h1 is accepted properly, means that mu is equal to 1 is much more important here. We have complete freedom over mu is equal to 1 region, like how much close it will be towards mu is equal to 1. So by having control over the level of significance, the alpha, and putting it on h naught and putting on h1, the game changes differently. In one case, having the control give us complete power of when to reject h naught. In other case, if we have if we fix the type 2 error and minimize the type 1 error, we have complete control over how much we should tolerate to accept h1. That means here fixing type 2 error is nothing but h1 is accepted first properly. Both are different. If you fix a type 2 error and minimize type 1 error, type 2, if you fix a type 1 error and minimize type 2 error, we are first rejecting h0 and then accepting h1. But if you fix a type 2 error and minimize type 1 error, we are first accepting h0 properly, and then hence we are rejecting h0 because h0 is not accepted properly. So the idea is different. Mathematically it's not different, but probabilistically it's different. We are first rejecting h0 properly, and then we are accepting h1. And here we are first accepting h1. We are making sure the h1 is accepted first, and then hence if it's not accepted, then we are rejecting. I mean, since h1 is accepted, hence we are rejecting h0. The two concepts the two directions are different. Now understand, when you select the null hypothesis, the goal of the null hypothesis is this, that you're making sure that it's rejected properly. That's the goal. If it's rejected properly, then we can select the h1 properly, and the test is built. The best test is built so that it's on the on the supporting side of h1. But understand the core difference. Here we are making sure h1 is rejected properly, that it's far away from -1, and here we are making sure it's close enough to 1, so that we make sure that h1 is accepted properly. So the goal between fixing the type 1 error and fixing the type 2 error is towards how the null hypothesis and H1 alternate hypothesis is approached. Okay, it's in the philosophical understanding. Null hypothesis is given, is there to make sure it's rejected properly, and alternate hypothesis has nothing role to play. It's like the opposite of null hypothesis by the way we approach the whole problem. So the statisticians should make it very clear, and they have made it very clear that H naught, by this whole understanding that how they have developed how they have developed. So I'm not telling something is not, something is wrong or right. It's how the whole thing is built. The whole thing is built in the way the null hypothesis should be rejected first, and then alternate hypothesis should accepted. So they often, when I learned in my college days, they have told it in this manner. They have taught it in this manner that imagine you go to a court and there is a person who is guilty. Okay, or so it's another person who is not guilty. Like, so it's like person A is guilty versus person B is guilty. Okay, or maybe person A is guilty versus in the meantime of the whole judgment another person comes out to be guilty. So the goal of the judge is to make sure that person one is, you know is not guilty to, or guilty to the to the perfection, to the tolerance level. Uh, so the judge should not be focusing on who among others who is guilty. His job should be focusing on whether the person in the H naught is, rejected or not properly, whether the person in the person who on whom the complaint is lodged, he or she is guilty or not. And then the focus should go on, okay, if this person is, he or she, this person is not guilty or guilty, if then the other person is guilty or some other person is guilty or not guilty. So the focus is first on H naught. If the focus is on H naught, it's making sure that it's rejected properly, and then H1 is accepted. So in this way, you can understand that H naught is meant. So the whole idea of testing is to make sure that H naught is rejected properly, and hence, if it's rejected, then H1 is accepted. So that's why we first fix the type 1 error, because and minimize the type 2 error, because people make mistake that we are minimizing the type 2 error because type 2 error is much more important. No, it's about how the whole hypothesis and whole philosophy of testing is. So we have the whole control over type 1 error, and that's a good. That means we focus more on type 1 error. We have control, and then we minimize the type 2 error. Type 2 error is minimized to, to focus on the H1 more, and type 1 error is to make sure that it's rejected properly to our tolerance level. So the idea is that I've discussed in one of the previous videos that type 1 error is to make sure it's rejected properly. H0 is rejected properly, is rejected in our tolerance level. That's by that I mean properly. And minimizing type 2 error is making sure that H1 is, if making sure that if H0 is rejected, then the test should favor or support H1. This is the goal. So the order of importance is H0 and then H1, not the other way around. And hence we select it properly. And hence we have to develop the test and the hypothesis, not the test, but the hypothesis statement in the corresponding order. Okay, how we should build up the whole hypothesis is in this whole. We first focus on H0 and then H1. That's the whole idea. I hope it helped understanding the whole concept of null hypothesis and why the hypothesis is defined in the certain way, and why the null hypothesis is defined in the certain way, and the alternate hypothesis is defined in a certain way, and why type 1 error is controlled and type 2 error is minimized. So I hope it made it clear, and also share your comment what you think. And yeah, thank you for watching till this point of time, and have a great day ahead. See you in the next video. Stay tuned and stay blessed. Bye bye.